In the first installment, we looked at common noise sources in conferencing environments and described how they're measured. In this video, we're going to simulate a noisy room environment to demonstrate the effect of noise on a microphone. We're going to explain this in terms of signal-to-noise ratio, which is simply the difference between our desired signal, in this case, my voice, and our unwanted signal, in this case, the ambient room noise. In the ideal case, we'd like our signal-to-noise ratio to be at least 20 dB, which means that the level of my voice has to be at least 20 dB louder than the ambient room noise at the position of our microphone. Let's first consider the noise. The loudspeaker here is going to be recreating our ambient room noise sounds so that we can dial in the level at the microphone precisely. We're going to dial it up to 40 dBA, which is at the top end of the acceptable range that we described in our last video. Now let's look at my voice. I'm currently seated about half a metre from the microphone, so from here, the level of my voice at the microphone will be somewhere between 60 and 65 dBA. In terms of a signal-to-noise ratio, we'll have at least 60 minus 40, which is 20, so that meets our target and the audio performance should be quite good. If I move away from the microphone, the level of my voice drops by approximately 6 dB for every doubling of distance. This is known as the inverse square law and is a common property of many physical phenomena. So, because my voice has dropped by 6 dB, we need to compensate by increasing the gain on the microphone by 6 dB so that the output level remains the same. The level of the noise at the microphone hasn't changed though, so now our signal-to-noise ratio will only be 14 dB and the noise will be noticeably louder. If I move back to 2 meters and again increase the microphone gain to compensate, you'll now be hearing the result of only an 8 dB signal-to-noise ratio. And finally, back at 4 meters from the microphone, you're now hearing the result of only a 2 dB signal-to-noise ratio. And I'm sure you'd agree, the result is completely unusable for conferencing. So how does the noise level in your conference room compare? Remember, you can easily measure the noise level using free apps for most smartphones, and reducing the noise could have a major impact on the quality of your conferences. If you think your room looks or sounds like it may have a noise problem, talk to your AV system integrator or acoustic consultant about how it can be improved.